Okay, gentlemen, today we're looking at 7.4 day one and the sine and cosine ratios. So first thing, what is SOHCAHTOA? SOHCAHTOA is something that we came across last day in class, and basically it is a summary or an acronym for the three primary trigonometric ratios. The first one is sine, the second is cosine, and the third is tangent. And the sine ratio is opposite over hypotenuse. The cosine ratio is adjacent over a hypotenuse, and the tangent ratio is opposite over adjacent. Okay, so that's what we're looking at when we look at SOHCAHTOA. It's just an acronym for the three primary trigonometric ratios, and that acronym will help you determine which side lengths assist you in coming up with the ratio or the decimal. So I wrote here in the learning goals for you, the three primary trigonometric ratios are sine, cosine, and tangent, and they are as follows. And then over here, I have pretty much cut and paste from the textbook, sine theta, opposite over hypotenuse, cos theta, adjacent over hypotenuse, and tan theta, opposite over adjacent, just like SOHCAHTOA. So there's your S-O-H for so, and the ka is C-A-H, and the toa is T-O-A. SOHCAHTOA. Okay, that's where that comes from. And then you can find any side length or angle measure of a right triangle if you know two pieces of information in addition to the right angle. So if you know the right angle and then you know the opposite or the adjacent or the opposite and hypotenuse or the angle measure and the adjacent or the angle measure and hypotenuse, etc. As long as you have two other pieces of information. And this first part, like the homework, I'm asking you to find the sine, cos, and tan for that triangle at right. So here's the triangle. The first thing I went ahead and used the Pythagorean theorem to determine the length of the hypotenuse, and I left it in exact as an exact answer. So the square root of 58. If you do this properly, you get the square root of 58 for the hypotenuse. And then for each of the primary trigonometric ratios, so here it asks for an exact answer and then rounded to 4 decimal places for each. So I start off with sine theta. So the sine of theta is, as we know in the SOHCAHTOA, opposite over hypotenuse. So if you're looking at theta, opposite is 3, and of course hypotenuse is 58. So it's 3 divided by the square root of 58. And if you use your calculator, you get 3 divided by the square root of 58. You end up with 0.3939. Okay, unlike last video, I actually figured out how to change the settings in that calculator, and I've got it now to 4 decimal places. So 0.3939 is what you'd have here. 0.3939. And then, of course, is it 3? Yeah, 3 over the square root of 58. That would be an exact answer. And rounded to 4 decimal places, 0.3939. Here we have, the next part asks us for cos of theta. And the cosine of that same angle, the cosine is adjacent over hypotenuse. We're looking here now, right, at this right here. So adjacent to the theta is the 7. Adjacent over the hypotenuse is 7 over 58. As you can see, I wrote that there. So that would be our exact answer, square root of 58. And then again, using your calculator, oops, let's go back, take that out and put 7 instead. 7 over 58 is 0.9191. That's really good enough, but 0.9191, that's going to continue. So technically, if we're rounding to 4 decimal places, it would be 0.9192. Okay? But I'm okay with 0.9191. Tan theta is opposite over adjacent. So if you're looking at, let's get rid of this. If we're looking at tan of theta, we're looking at opposite, again, 3 over the adjacent, which is 7. So 3 divided by 7. And take my word for it, when you type in the calculator, you get 0.4285. Again, that's good enough. If you put 4 decimal places, no problem. And so we get 0.4285, and this is 3 divided by 7. Okay? And that would be what you'd find interesting, or hopefully you'd find interesting, if you take the sine inverse of that angle and the cos inverse of that, or the tan inverse of that, you'd get the exact same angle. So for example, 0.4285, if we did the tan inverse of 0.4285, oops, that's supposed to be a 4, you get 23 degrees, rounded to 23 degrees. If you took the cos theta, so 0.9192, cos inverse of 0.9192, you get the same angle, 23 degrees. And then sine of 0.39, sine inverse of 3939, so sine of 0.3939, you get the same angle, 23 degrees. So the three primary trigonometric ratios all come up with the same angle, and we should come up with the same angle because we want to have we're talking about the same angle. So no matter which ratio you use, you should get the same angle measure. So here's us find the three primary trigonometric ratios for angle A to 4 decimal places. So basically what I just did above, I want you to do that with this right here and write out your work properly. Please write down the relationship first and then follow through with your exact and actually here I was asking for 4 decimal places. And then I want you to calculate the sine of angle 51 and answer these two questions. Is the angle measure in degrees or a ratio of sides when you do that? And is this giving you an angle measure or degrees in degrees or a ratio of sides? So do that on your own and we'll see you in class.